So while the disk method did pi r squared, this one does 2 pi r pretty much. So you're doing kind of a summation of the surface areas versus a summation of the volumes. So instead of pi r squared, you're using 2 pi r, which is where they come up with the formula here. The shell method. The shell method is going to be exactly opposite of the disk. All right. So if you are doing a horizontal revolution, you will want it in terms of y. If you're doing a vertical revolution, you'll want it in terms of x. Okay. So disk is exactly opposite. In fact, we're going to look at the two compared right after these two examples. And so you have to think about it. If they're doing the x-axis or anything parallel to the x-axis, y equals a number, that is a horizontal axis of revolution, and you want it in terms of y. If they're doing vertical, so y-axis or anything parallel to the y-axis, that is a vertical revolution, you want it in terms of x, okay? So let's look at this example. The volume of the solid revolution formed by revolving the region x minus x cubed around the y-axis. That is a vertical revolution, so we want it in terms of x. It is in terms of x, so that's beautiful. And they tell us from 0 to 1. So if it's in terms of x, then your boundaries need to be your x's as well. So you have to kind of check off the blocks. It's the axis of revolution is actually x equals 0, right? That's the y-axis. Your x's are your boundaries, and your function is in terms of x. And so that's what we're looking for to do this shell. And so then you're just going to set it up. You're just going to say, okay, I'm going from 0 to 1. I want 2 pi r times my height, so 2 pi. My radius here, because my axis is the y-axis, my p of x is going to be just x. The distance from the y-axis is just your x value. And so we are going to use x here for the p of x piece of it. And then my f of x is my other piece. My height is my x minus x cubed, that function. And of course it is in terms of d of x. And then it's just a basic, I mean, you have x squared minus x to the 4th. That's what I am differentiating here. So I have 2 pi. I'm taking the antiderivative of this guy. So I have 1/3 x cubed minus 1/5 x to the 5th from 0 to 1. And then it's just straight, 1/3 plus 1/5, right? 1/3 or minus 1/5 rather, times 2 pi. We have our common denominator of 15, so we get 5 minus 3 times 2, so we get 4 pi over 15. The axis of revolution is my x-axis right here, x-axis. All right. So for this one, though, you do have to do U-substitution. All right. So they have it all set up right. I have it in terms of y. I have my boundaries. I have a horizontal. So I have it set up the way I want it. I do have to do 2 pi. Now my p of y here is my distance from my x-axis. So now I'm going to use a y there, y, and then my function is my h, so e to the negative y squared dy. All right, now this guy is u substitution. All right, so my u here is going to be that negative y squared. My du is going to be negative 2y dy. I just need a y. So I need to multiply both of these by negative 1/2, right? So negative 1/2 du will give me my y dy, which is what I want. So I actually end up multiplying this guy by negative 1/2. So I have negative 1/2 2 pi from 0 to 1, but all of this is replaced with this guy. So I have e to the u du. So these basically cancel. So now I'm just taking the antiderivative of e to a function. That's just e to the power, right? So this is just going to be e to the u, but my u was negative y squared. So e to the negative y squared. I still have that pi there, and I'm going from 0 to 1, right? And so it's going to end up being just e to the negative 1 times pi, which is approximately 1.986, right? So easy enough. All right, question here. The first one represents your disk method, okay? So you basically have your outer shell squared minus your inner shell squared. That's your disk method, pi r squared. Okay, so for this one, you're thinking pi r squared for these two, okay? For this one, you're thinking 2 pi r times h, right? That's your basic geometric formulas that you're thinking of. So disk method, you're gonna do outer shell minus inner shell and then take the revolution, all right? Now, if you are revolving a vertical, you want it in terms of y. So this is like, for disk, if it's the y-axis or anything parallel, then you want it in terms of y. X-axis or parallel in terms of x. That's disk. Shell is exactly opposite. If I am doing a vertical, so y-axis, I want it in terms of x. X-axis in terms of y. So you see the difference in the disk and the shell. The revolutions make the world of difference. Why does this matter? Because sometimes it is easier to do shell over disk based on what function you've been given. So look at this next example. Right. So for this one, I have y equals x squared plus 1. They want me to go around the y-axis, all right? So y-axis, that's here. They want a vertical revolution. So for a vertical revolution, if I am going to do the disk method for a vertical revolution, then I need this in terms of y. All right? If I'm doing a shell method, then I want this in terms of x. All right? Now, you could do this one in terms of y if you wanted to. You could say square root of y minus 1. All right? It's not beautiful, but you could do it. However, because of your limitations here, you have a 1. So you would have, oh, he jumped. You have this 1 here. So you would have to say 1 squared minus 0 squared. Like you would have to really set this guy up for two different things. See, if you look, this was an example before. So from here to here, you'd have one type of revolution. And then from here to here, you have a different type. So if you look at a vertical revolution here in terms of y, you have a hole for part of it and you don't have a hole for the other part of it. So you would actually have to do two different things. You'd have to do one for this piece and one for this piece. So for this, shell method is way easier. I'm going to use shell. It's kind of already set up for me. So I'm going to say 2 times pi. I am going to go, it's in terms of x. So they've already given me my x's, 0 to 1, right? And then my distance, so my p of x is just going to be x. My function is going to be the other piece of it. And that is going to be way easier than trying to do disk method here, okay? Disk method is going to do two different ones. Disk method would do from 0 to 1 and then from 1 to 2. You would actually have to do two separate antiderivatives here. So this one's going to be way easier to do at this method. So I'm going to say 2 pi. Of course, this is x cubed plus x. So I'm going to say 1/4 x to the 4th plus 1/2 x squared from 0 to 1. And I'm going to get 3 pi over 2, which is actually the same thing that I would get if I did disk method. It would just take a lot longer to do disk method.